Hello everyone, and welcome to a video on algebra shortcuts everyone should know. These shortcuts will greatly increase your speed whenever you're algebraically manipulating equations or solving for unknowns. And they'll come in handy in any class that you're taking in science or mathematics, anywhere. And these will be very simple shortcuts that anyone could learn. And so we're going to start off with some multiplication and division, which personally I think is kind of the easiest to see. Then we'll go on to some addition and subtraction, some short ones on exponents, not too much, and then we'll put them all together with some examples. And in the examples, I'll try to really point out where they come into practice and how you can see them. And so if you just think you want to see the examples, please feel free just to skip forward there and watch those in action. Thanks very much for stopping by, and let's get started with some multiplication and division. So to start with multiplication and division, let's look at a simple equation here. Where let's say we have a constant a multiplied by x is equal to another constant b. So these constants are just numbers, they can be any number. So how you would solve this normally is you would divide both sides by a to isolate x. On the left side, these two a's cancel and simplify to 1, and we are left with x is equal to b over a. And that's great. How we can visualize this a lot simpler is if we look at the exact same equation, ax is equal to b. We can look at this a being multiplied by the x, and we could move that diagonally across the equal sign below the b. So then what we can just do is just go directly to the final part where it's x is equal to b over a. And there you go, you have your final answer right there. This might not seem like we're saving a lot of time, but if we look at something maybe a bit more complicated, well, let's say that we have 4x times y squared is equal to 3z, and we want to solve for x here. What you can do is you can just look at this and go, okay, we have a 4 and a y squared. We can take those both and push them diagonally down across the equal sign. And so then what we have is that we can just look at this equation straight up here and just go right to the final answer and just go x is equal to what we have on this side, 3z, and then we just move everything else, just dump it right below. So we have 4y squared, and that's your answer here. And so the other way we can look at this, if we look at another simple equation, where let's say that we have x over a is equal to b. And so then we want to solve this. Same thing. How we would do this normally is that we multiply both sides by a, where we have the a's cancel on this side, they simplify to 1 again, and then we are left with x is equal to b multiplied by a. So what we did here is we just simply took this a and we pushed it up diagonally across the equal sign. And so where the big picture of this is that you can constantly visualize each side of the equation as, let's say, a over b is equal to c over d, where you could look at these levels here, where let's say if you wanted to solve for a, you could just take this b and push it up across the equal sign, and then you will be left with a is equal to bc over d. Whoops. And so let's say you wanted to solve for c here, or same thing, you would just take this d then and push it up across the equal sign and solve for c. So then we could just jump right to the answer and just go, okay, c is equal to ad over b. And so when we look at the big picture of the multiplication and division, is let's say that we have 3y squared x over 2z is equal to, let's say, just a. And so we want to isolate here for x. And so what we can do is we can look at this now as just what here is on the bottom. We can push up across the equal sign. And then what here is on the top, we can push down across the equal sign. And so let's do this one step at a time here on this one, and let's get rid of this 2z first. So let's push that up. And so what we're left with is we have 3y squared x is equal to, then let's just push this up here, 2z times a. And then what we can do here is we can just take what's left here, the 3y squared, and push that across the equal sign diagonally below what's on the right. And so then we're going to be left with x is equal to 2za over what we have here, just push below, 3y squared. And so I did this in 2 steps here, but if you practice this enough, what you'll be able to do is, let's just, let's do another one here. Let's do 4z times p x over 3y to the 4 is equal to b. And so let's try to do this in 1 step here, where we want to solve for our unknown x here. And so what we can do is just push what's on the bottom up on the b, and then what's on the top down below the b. And so if we throw this in action here, we are going to be left with x is equal to, push this up diagonally, 3y to the 4 multiplied by b all over 4zp. And that is your answer. And so instead of constantly multiplying and dividing each thing out every time, you could do this almost in 1 step if you really want to, and just kind of solve it as you write it out. So that's kind of the big picture here, is that you can just move things diagonally across the equal sign as long as it's multiplication and division. And so we'll see more of these examples in the end when we put it all together. Okay, now let's move on to addition and subtraction. So let's say we have a simple equation here where we have x plus a is equal to b. Same thing, where a and b are just constants. And how you would solve this, normally using writing out all of the rules, what you're doing is you would minus a from both sides. So we have x plus a, and then we minus a is equal to b minus a. Where then plus a and minus a simplify to 0, so then you're left with x is equal to b minus a. And so what we had here is that we had plus a on the left side, and we ended up with minus a on the right. So how I kind of visualize this one as a shortcut here is, if you have x plus a equals b, I visualize the equal sign as kind of being a plane. And you can just take whatever you want from each side, if it's added or subtracted to the equation, and if you take it, you can push it straight through, and it changes the sign, and you flip it and put it on the other side. So if we have x plus a equals b, I simply take this plus a and move it over to the other side and make it negative. And so then we have x is equal to b minus a. Let's see an example of this with some more terms or whatnot. So if we have x plus 3y squared minus 4z is equal to b, where b is just a constant. And so we'll do this in a couple steps here. So let's take this 3y squared and push it over and change the sign and just move it straight over to the other side. So then we're left with, on this side, x minus 4z is equal to b, change the sign of what we pushed over now, minus 3y squared. And then let's look at this minus 4z. We want to push that over too. And so we're just going to move that directly over and change the sign. So we have x equals b minus 3y squared. Take that 4z, push it over, change the sign so it's plus 4z. And there you go. So let's do one more example here and then we'll move on. So if we have x plus 2b minus 3c plus 4d is equal to z. So let's do this in 1 step here. So what I'm going to do is just write out the x equals what we already have on the right side, z, and then let's just move this over now. So that 2b, we're just going to flip the sign, move it over, minus 2b. Great. Now this minus 3c, move it over, flip the sign, 3c. There you go. This 4d, move it over, flip the sign, minus 4d. And there you go, you're done. When it's addition and multiplication, is you can just kind of look at these as individual chunks and just simply push them across the equal sign and just flip the sign on them. Okay, so when we look at exponents, this one is just more so for simplifying one side of the equation. So if we look at something, let's say a fraction that we just have 1 over x to the minus 2. How you normally would simplify this is you multiply the top and bottom by the opposite. X squared in this case, if we have x equals minus 2. And what we get here is we're left with x squared on the top over x to the minus 2 plus 2. And this one here is just going to be equal to x squared over x to the 0, where x to the 0 is just going to equal 1. And so we're left with x squared. The shortcut here is that if we have 1 over x to the minus 2 on the bottom, and then we ended up with x squared, how I visualize this one is that I look at it as, if you have a division sign, is that you can take whatever you have on the bottom and you can push it directly up, and then the exponent changes sign. And so in this case, you have 1 over x to the minus 2. And so what I do here is I take this x to the minus 2, I push it up. And so we look at this as x to the minus 2, we pushed it up, and then you change the sign. And so then you are left with x squared. And so I visualize this one as when you have the division sign, you can push whatever you want through either way, and then you just change the sign of the exponent. Let's get more variables in here to make sense of this. So if we have x squared times y to the minus 3 over z to the minus 4. Okay, so let's say we want all positive exponents. So the x squared is just going to stay on top. We have x squared. And then this y to the minus 3, what we can do is we push that down and change the exponent. Change the sign of the exponent. So we have y cubed then. And then we take this z, we push it up and change the exponent. So then we have z to the 4. And then you're done. So you kind of skip this long, proper way of writing things out, which is really what you're doing in the background. That's the short method for simplifying exponents. Okay, so let's start doing some examples here. So let's look at the equation here. E is equal to IR, which is Ohm's law from electricity. And let's say that we want to solve for R. And so using the shortcut is we will just take I and push it diagonally across the equal sign. And so then we will be left with E over I is equal to R. And there you go, you're done. Now let's look at this. PV is equal to nRT, and we want to solve for T. So let's take the N and the R, push it diagonally across, and we are left with PV over NR is equal to T. Done. And so here we have RL is equal to G2 minus G1, and say we want to solve for G1. And so first what I'm going to do is just push the G1 over to the other side to make it positive. So then we're going to have G1 plus RL is equal to G2. And now we can take the RL, push it over to the other side, change the sign on it. G1 is equal to G2 minus RL. And there you go. Now let's look at another example. W equals ST minus Q. And let's solve for Q. So let's take this Q, push it over to the other side, make it positive. Q plus W is equal to ST. Now let's take the W, push it over to the other side, and make it negative. Q is equal to ST minus W. And there you go. And so if we want to do this, and we can look at this as one step as well. So let's write this out again. W equals ST minus Q. So if we take this Q, we can push it over, make it positive, and we can take this W and push that over. First, the Q comes over and becomes positive. Q is equal to st minus w on this side. And there you go, you're done. So you can do this in one step. Okay, so here's another example. L is equal to n phi over I. And let's say that we want to solve for phi. And so we can look at the I, we can push that diagonally up, and the n, we push that diagonally down. So then we are left with L multiplied by I from pushing the I up, and then pushing the n down, over n is equal to phi, and we are done in one step. Okay, here's another equation, and let's say that we want to solve for m2. So first, let's take this m1 and push it up. So we have k1 multiplied by m1 all over k2 is equal to m1 plus m2. And now we can take m1 here, push it over, and make it negative. So then we are left with k1 m1 over k2 minus m1 is equal to m2. And there you have it. And so let's try to do this in one step and push the visualization of this just a little bit farther. So let's rewrite this. So let's solve for m2. So first, we push the m1 up. And so that we are going to have k1 m1 over k2. So we push that up. And then what we're going to have left on this side is m1 plus m2. So then we can move the m1 over, change the sign of it, minus m1 is equal to m2. So there you have it, how you did it in one step. Okay, so here's another one, and we are going to solve for d. So first, the whole bottom here, d minus f, we are going to push that entire expression up. So we are going to be left with f multiplied by d minus f is equal to f. And now we have f multiplied by this whole number, so we can move this f diagonally down. And so then we are going to be left with d minus f is equal to f over small f. And now we have this f that we need to push over and make positive. So we have d is equal to big F over small f plus big F. And there you have your answer. Let's see if we can do this in less steps. So if we have f equal to big F over d minus f. So now let's do this first one in one step here where we can take the d minus f up and the big F down. So then what we have is we're going to have d minus f is equal to big F over small f, and then we just have to move that f over like we did before, and we are left with d is equal to f over small f plus big F. So this is where it comes in handy, where you can just simply exchange each side of the equation. Okay, so another similar example, and now let's solve for big M. So let's try to do this in as little steps as we can. So this whole bottom part, we are going to diagonally push it up across the equal sign, and we can switch it with this a. So we can just swap these directly. So then we're going to have m plus 2m is equal to 2mg over a. And then we just take this 2m and move it over. 2mg over a minus 2m. And there you go. Final answer. Okay, here we have another one where we are going to solve for v. So if we push that c1 down, we have c0 squared over c1 squared is equal to 1 plus 2v. Now we move that 1 over, c0 squared over c1 squared minus 1 is equal to 2v. And now we're going to simplify this side. If we take the c1, multiply the 1, and turn that into a common fraction, we have c0 squared minus c1 squared all over c1 squared is equal to 2v. And then we just have to push that 2 down, and then we're going to come up here. We have c0 squared minus c1 squared all over 2c1 squared is equal to v. And there we go. And another one where we are going to be solving for m. So let's take that a and push it over. And so we have a1 over a, and let's try to do this in one step. So if we push that a over, we are going to be left with m plus 1 on this side. So we can take that 1 now and move that over and have the minus 1 is equal to m. And so I'll write this out in a couple steps in case that was a little fast. So we push that a down, a1 over a, and then we're going to be left with m plus 1. And then you just have this 1 here to push over. And so then that's going to be a1 over a minus 1 is equal to m. And there you have it. Okay, here's another one. We are going to solve for s. So let's take that r and push it down. So we have n over r is equal to a minus s. Now let's take that s and push that to the left and change the sign. So we have s, and then we're also going to take this n minus r and move it over and change the sign. So we have a minus n over r. Okay, and another one, and we are going to solve for t1. So let's take that 3, move it down. We have t over 3, and then we are going to be left with on this side t2 minus t1. So let's just write this one out here because the t1 is minus. Okay, and so now let's take this t1, push it over, and take this t over 3 and push it over the other way. So we're going to be left with t1 is equal to t2, and then move that over, change the sign, t over 3, and there we have it. Okay, here's another one, and we are going to solve for h. And so first thing let's do here is let's take the h over 100 fraction and add that to both sides, move it over, and then take the t2, move it over and change the sign. H over 100 is equal to t1 minus t2. And then we just simply move this 100 up and multiply the whole side by it. So then we're going to have h is equal to 100 times the whole right side. And this is a good one to kind of look at and see how this really happens, is that when you move it across, it has to multiply the entire side. So you can't just look at this from this step and go like here. You can't just go h is equal to 100 t1 minus t2. This is very wrong. You have to always remember it's by the entire right side. Okay, so we have this equation here. We're going to be solving for r, and this seems like it'll be fairly difficult with lots of expressions in here, but we can do this one here in one step really if we really want to. So first we move this p1 over, change the sign, so we're going to have p2 minus p1, and then if we look what this r is, we're just going to have this on the right side left, and then if we move this whole portion down, p1 multiplied by this whole thing, you can write that all over p1 times 1 minus p1, and there you have it in one step. And I'll do this one in two steps here, just in case that was a bit fast. So let's do the first step here, where we move the p1 over. So we minus p1 is equal to r p1 1 minus p1. And so now we see on this side, we move this whole thing down across. So then we're going to have p2 minus p1 divided by that whole thing that we moved over. And there you go. And so I hope this is starting to make sense, kind of where these shortcuts can save you lots of time by looking at these by kind of chunking these numbers together and looking at moving them as big groups instead of trying to do the traditional method of multiplying and dividing each side or moving one thing across at a time, how you can kind of look at this as big chunks to get through questions. Okay, and here's another one, and we are going to be solving for Q2. So let's get rid of that P, Q1 over P, and then we're going to be left with that Q2 minus Q1. So if we take that Q1 and move it over, And there you go. So I'll do this one in a couple steps here so that you can just see what I really did. So if we move that P over, we're going to be left with Q2, sorry, it's Q1, minus Q1. And then we were isolating for Q2, so we're going to take that Q1 and push that over, and we're going to be left with Q1 over P is equal to, plus Q1 is equal to Q2. And if you really want to simplify this one again, but I think that is up to personal preference, and there we go. Okay, in another equation, we are going to be solving for y2. So the first thing that we can do is we can take this dg, move it under, and then we'll be left with the y2 minus y1, where we could just move the y1 over. So if we want to do this in one step, we move that dg diagonally down below the left side, and then we have y2 minus y1. So then we can take that y1, push it over, and become positive equals y2, and there we go. And I'll just again show this in two steps. So P minus PA divided by dg, and then what we'll have left is y2 minus y1, and that's where we can take that y1 and move it over and flip the sign, where then we'll be left with what we have here. Okay, and the next one. So now we are going to be solving for n1. So what we can do is we can look at this entire expression here, move it across the equal sign and change the sign. And then we'll be left with n1 times t, where we can divide each side by n1. So this can be done in one step, but I'll just maybe start this one in two steps. So we'll have n, move this over, plus n2, 1 minus t, so got rid of that whole chunk at once, is equal to n1t, and then we want to move this n1 down, so then we are going to be n plus n2, 1 minus t, all over n1 is equal to t. And so this here is a good example about how when you push this down, you have to make sure that you're doing it across the entire side, and not just, one of them. Okay, here's another one, and we are going to be solving for h. So first off, let's take this TC and let's move that over and change the sign since it's addition, minus TC, and then we'll be left with this entire side, or this entire expression on the right, where we can divide by TM. So let's do that in the first step there. Divide by TM, and that's going to equal 1 minus h. And then here, if we look at this where we have this minus h, we can move that over that side and change the sign, and we can take this entire side and move that over and change the sign. And so if we do that, we're going to be left with h is equal to 1 minus TA minus TC over TM. So the big trick here is that once you have this expression, is you treat all of this as one big chunk, one number, and then it's easier to manipulate. So here another example, and we're going to be solving for R1. So this one looks really daunting at first, but we can see how we can use these shortcuts to really speed up the process now. So on the right side here, we have this 2x1 and x2. And so we can simply move both those over and change the sign. So we're going to have L minus 2x1 minus x2 is equal to pi times r1 plus r2. And then same thing, we just move that pi over. And so diagonally across the line, that is L minus 2x1 minus x2 over pi is equal to r1 plus r2. And then now we can just take that r2, move it over and change the sign, where we have our final answer, L minus 2x1 minus x2 over pi minus r2 is equal to r1. And there we have it. And another equation here where we are going to be solving for mu. And so we can look at this, get this bottom done with, where we can take that R1, R2, move it up diagonally. So we have I, R1, R2, and then that bottom is going to be gone. So we can take this VR2, move it over and change the sign, minus VR2, and then we're going to be left with this VR1 multiplied by 1 plus mu. So then if we take that VR1 and we push that diagonally down now across the whole side, VR1, and then we're going to have 1 plus mu left on the whole right side. So we can just take that 1 and push it over, minus 1 is equal to mu. Now I'll do this in more steps, but that's just to show you how it can be done in one step and slowly break it apart if you really want to. So, okay, so here we have this again. Let's move that R1, R2 up. I, R1, R2, VR2 plus VR1, 1 plus mu, and then we want to move this over. So just move it over, change the sign. Minus VR2 is equal to VR1, 1 plus mu, and then we want to move this diagonally down across the equal sign. So we're going to have I, R1, R2 minus VR2 all divided by VR1 equal to 1 plus mu, and there we can just move the 1 over, change the sign, and then we are going to be left with I, R1, R2 minus VR2 over VR1 minus 1 is equal to mu. And there you go, where we have, so here we did it multiple steps, where if we go back up, we have how you can kind of do it directly in one step by slowly picking it apart and using these shortcuts in combination. All right, this one we are going to be solving for V2. So let's slowly try to do this in one step here. So first, let's write our left side. We have P. And now let's take this GJ, move it up. So it's going to be P times GJ. And then we're going to take this V1, move it down over V1. And then we're going to have V2 minus V1 left. So let's take that V1, move it over and add, plus V1 is equal to V2. And that's how you can use these shortcuts in combination again to solve things very, very simply. Okay, and another one, and we are going to be solving for S2 in this case. So the first thing we need to do is take this Q and move it over. So if we take that, we're going to have Q, or W, change it over, change the sign, plus Q, and then we're going to be left with this expression on the right. So let's move that T over. We're going to have T equals S1 minus S2, and we're solving for S2 in this case. So now let's take this S2, push it over and change its sign, and this entire fraction, push it over and change its sign. So we are going to be having S2 is equal to S1 minus W plus Q all over T. And there you have it, we are done. Okay, and now we have this one here where we are going to be solving for E. And this one looks, again, very daunting off the start, but this one is easily be done in one step. So here, let's write C first, and then let's take this whole bottom, and we are going to push that up diagonally across the equal sign. So then we are going to have D times K1 plus K2, and then we are solving for E, so we are going to take the 2A, K1, K2, and push that all down across the equal sign, and we are going to be left, we're going to have 2A, K1, K2, which is equal to E. And there you have it, one step. Okay, and now we have this equation where we are going to be solving for L. And so, first what we want to do is take the bottom, move it up diagonally, so that is going to be D6, E, I, and then we are going to be left with 3lpx squared minus px to the cube. So we are just going to move that over, change the sign, plus px cube all over, and then we are just going to have left this on the right side after we do that move. So then we can just move what is left down across the equal sign to the bottom, and we are going to have 3px squared is equal to L. And there you have it. Okay, and another one, and we are going to be solving for small n. So the first one we want to do is get rid of the c. We're going to v over c equals 1 minus n over n. And then let's switch these and just change the sign on them. So we are going to have n over big N equals 1 minus v over c. And then we can just take this n, move it diagonally across the equal sign. It's going to come over here where we have n is equal to big N multiplied by the whole side v over c. And there we have it. Okay, and then in this example here, we are going to be solving for b. So the first thing we want to do is take this whole bottom and push it up diagonally across the equal sign. And at the same time, we can take this q and push it down, and this p and push it up. So if we move this, let's write first the b plus a I, and then we are going to have on this side ai, where we took this p and we push it up, so that's going to be multiplied by p, and then we took this q and we push that down, and that is going to be over q. Okay, so again, we took this bottom, moved that up, at the same time taking this q, moving that down, and this p, moving that up. And so now we are left with this, where we need to isolate for b. And all we have to do is take this ai, move it over, change the sign. So there, we are left with b equals aip over q minus ai. That is your final answer. Or if you did want to simplify more, maybe you could factor out an ai to make this more compact, minus 1. Oops, where this is ai. So this is kind of optional. I think they're both pretty much the same, but that's that question. Okay, well, thank you guys very much for watching. I hope that helped and you guys understand what was going on with the shortcuts. This is my first video kind of doing something like this, so I hope to do more of these in the future. So please let me know if you enjoyed it, if it went too fast, if it was too slow, if you kind of understood it or liked it, what you'd like to see in the future, anything. Any feedback would be greatly appreciated and greatly helpful for making future videos. So thanks very much, guys. Best of luck with your math in the future, and I hope you can put these shortcuts to use and save a lot of time. Again, thank you guys very much. Have a good day, and thanks for stopping by. Hopefully see you on the next video. Bye-bye.